morning, everyone. My name is Sardrash, and today I'm going to present as a process engineer involved in design phase of liquefied natural gas, or we call as LNG, and the liquefaction and export terminal. The purpose of this pitching session is to recommend the management prioritize inherent safety principle during the early design stage of the facility. LNG terminal handles large quantity of cryogenic and flammable material. LNG is stored and transferred approximately around negative 160 degrees Celsius. At this temperature, the material not only extremely cold, but it also can create a serious fire, explosion, and structural failure risk if it's accidentally released. The main process safety issue that I want to highlight today is cryogenic LNG spill and structural embrittlement. If LNG leak from transfer line, storage connection, flank, or marine loading arm, the liquid can spill into the nearby structural steel. The standard carbon steel is not suitable for extreme low temperatures. So when it exposed to LNG, it can cause to lose its toughness and it becomes brittle. So instead of bending or deforming slowly, the steel might crack suddenly, or it can cause a big pipe rack support nearby structural to fail. So the danger is not stop at one leg. It supports structural collapse. It may damage nearby hydrocarbon line, electrical cables, or mixture refrigerant piping. This can create a domino effect where one failure leads to a much larger or explosion event. For an LNG export terminal, this type of incident can affect workers, marine loading operation, and nearby equipment, environment, and the company's reputation. So to manage this hazard, I recommend applying inherent safety principle of attenuation and simplification. The first design solution is to use cryogenic-rated material in area exposed to LNG service. For example, piping and equipment operating at low temperature should not be suitable materials such as stainless steel or 9% nickel steel. This material can maintain strength and toughness at cryogenic temperature. This reduces the chances of sudden brittle and cracks, which lead to other explosions and flammable stuffs. So the third and most important the second solution is to protect nearby structural steel using passive fire and cryogenic protection, especially around the LNG transfer line, strong connection, storage connection, and loading area. This provides additional protection if the leak occurs and gives the operators more time to isolate the source. So the third and most important inherent safety solution is to design gravity flow drainage system to remote impound basin. Instead of allowing spilled LNG to spread under the process of the equipment, the plant layout should become included with slope trenches that direct the liquid away from the people, ignite sources, and critical structural. The LNG would collect in a remote impounding basin designed for cryogenic service. This simplifies the emergency response because the spill is automatically directed to a safer location without depending only on human action or in active control system. So from a safety perspective, this approach helps to prevent structural collapse, limits vapor cloud formation near congested equipments, and reduce the risk of escalation into major fire or explosion. This also protects the workers, contractors, emergency responders, and nearby communities. From a business perspective, early investment in inherent safety is more cost effective than modifying the plant after the construction. If we ignore this issue during the design, we may need to later need expensive blast walls, additional shutdown system, or major layout changes. The safer design also reduces unplanned shutdown, equipment damage, insurance risk, regulatory problems, and reputational loss. Therefore, my clear recommendation is that management should approve the use of cryogenic-rated material, passive cryogenic protection, and gravity flow drainage to remote impounding basin as a part of LNG terminal design. These design choices may increase the initial project cost slightly, but they significantly reduce the probability and consequences of the major accident. In conclusion, the process safety must build into the plant, not added only after the plant is completed. As an engineer, our responsibility is to design a facility that's not only productive but it also safe, reliable, and sustainable throughout the operation life. Thank you. That's all from me.